Good morning, students. Here you can see that the design factors. The name of the chapter in the syllabus, you will find that it's like axle configuration or traffic configuration in pavement design. So obviously you have heard about this many times that design factors are like the traffic loading, the environmental factors, the material characteristics, and the failure criteria. So I'm not going into the details about it. I'll be talking about the axle configuration from here. In case of the axle configuration, it's coming from the traffic and loading. So axle loads, repetition of loads. So these are the factors which are responsible along with the contact area of the tire. So here you can see that different axle configurations are there, which are having different type of loads. So single axle with single wheel, as the picture suggests, is having a 6 ton of load. Then single axle with dual wheel, which is having 10 tons of load. Now tandem axle. Tandem axle means two axles will be there and both of them having the dual wheel. So it is having a load of 18 tons. And the third one is tridem axle, which means the three number of axles having dual wheel will be loading 24 tons. Now obviously for trucks, this kind of configuration can be seen. Two axle truck, front axle and rear axle. Rear axle is having a dual wheel assembly, which is having a 16 tons of load. Then three axle truck. Three axle truck means front there will be one axle and in behind there will be two axles, which will be again dual wheel. So it will be having 24 tons of load. Similar way, four axle truck is there. Four axle articulated trucks are there. Okay. Now the factor is that articulated and semi-articulated means that difference in their loading configuration. Obviously, in this particular picture, we can see that a middle axle is there. Obviously, in this particular picture, also one middle axle is there, but the difference is between the carrying capacity or loading capacity. This will obviously carrying the load partially, and here this particular axle will be, this will actually carry the load totally. Here 5 axle truck is there. So 1, 2, 3, 4, 5. This is the configuration. Along with this one, there is an LCV. Okay, commercial vehicles having capacity of carrying the lower weight. So LCV is there, light commercial vehicles. Now we have seen till now that these are the configuration, but what are their effects? Obviously, the distance has been shown in this particular diagram. Now the effects of the axle load, you can see that axle 1, 2 and 3 on stresses and strain within the pavement. So 1, 2 and 3, this 2 will consist of 3. So they will be carrying some load and they will be affecting the pavement. Now within the group of axles, this one, axle, each axle cannot be considered as independent. So when they are standing in a group, that means these two axles will be considered as the equivalent, not the individual. So this is not 3 or 4. This total, these two axles are 3. So that means they are not considered as independent. Now here will be the repetition of the load. Obviously, we have heard in the elastic theory that repetition of load can be caused due to, in this particular type of pavement, because of the traffic loading. So repetition will cause fatigue, and as a result there will be some stresses that will be generated and subsequent failures will be there. So In case of the repetition of axle load, we need to convert the axle into the equivalent standard axle. So from there, ESAL, that is the equivalent standard axle load, is coming. Standard axle, obviously for dual wheels, standard axle is having 80 kilonewton of load, okay, or 8 tons in other words. So this is a standard axle. Now there is another term, tire pressure and contact pressure. From the picture itself, you can see that tire pressure is such pressure which is within the tire, and when it is making contact with the road surface, then the contact pressure will be coming. Now, what are their values? When the wall of the tire in compression, that means the air pressure inside the tire is lesser, okay, lesser with respect to the total load, or sorry, the standard value of that particular pressure. You have obviously seen that when the people are going for the repairing of the cars, in case of the pumping the wheel, the people used to check the pressure of the tire with the help of a pressure measuring device. So when there is not much air pressure, that is less than the standard value, in those cases the wall of the tire will be in compression, and in that case it is known as the low pressure tire, and here the contact pressure will be higher than the tire pressure. So that means it is having lesser pump in general terms. Okay. Now, when the wall of the tire is in tension, that is, the tire pressure is higher with respect to the standard value. In those cases, the tire pressure will be having a higher value than the contact pressure, which is known as the high pressure tire. Okay. Now the standard value. The standard value is somewhat 700 kPa. Okay. The standard value of tire pressure as well as the contact pressure. So when they are similar, they are 700, the tire pressure will be equal to the contact pressure. And what will be the effect if tire pressure or contact pressure reduces? We have seen in the previous slide. Next up is the contact area. It is the contact area is the true shape of contact area is elliptical. That means when the tire is making contact with the road surface, it will be making some impression on it. So the true shape is elliptical. However, in most of the cases, we generally consider it as the elliptical due to the fact that the tires are rounded, and when they are making the contact with the road surface, they are having the rectangular impression, but if you see the edges, they will be rounded. So they are considered as the elliptical. And there is a formula: if the contact area is A, then the relationship with the wheel load and the contact pressure is A equals to root under P by small p pi. So remember, wheel pressure or wheel load is capital P and contact pressure is small p. Okay. Now obviously the shape of the contact area, we have said that it is elliptical, and which is having this kind of dimension. So the contact area is given by AC is equal to 0.5227 L square, where L is the length. Okay, but the equivalent area is somewhat like this. When we are going for 5227 L square formula, we have derived it from here, but equivalent area concept is somewhat different. So equivalent area will be the equivalent area of this particular ellipse. So it is having a rectangle, it is having height of 0.6 L and the width of 0.8712 L. Okay. Wheel load versus contact pressure, again, this kind of relationship can be obtained. You have obviously seen in case of the equivalent single wheel load, a straight line relationship was obtained, but here, as it is not a straight line relationship, it is having an elliptical relationship, then the curve will be like this. Now, wheel load versus contact load, I am not going into the details about it because the magnitude of the contact pressure determines the quality and the thickness of the binder forces, but the total thickness of the pavement is mainly determined by the magnitude of the load. Okay, so I will be sending you this PDF where somewhere you can easily read it out. Now comes the vehicle speed, another factor responsible for the pavement design. Obviously, in other words, it is known as the design speed, and also this will affect the geometric design. Environmental factors are obviously there. We have heard about the temperature effects in case of the rigid pavement in our previous lectures. Also, we have heard about the rainfall scenario in India. So, if the rainfall is higher, so the camber will be steep. So, these are the factors. Moisture variations also, the material quality will be depending upon that one. Material, again, in case of the textual pavement, they are prepared with the aggregate and bitumen, and in case of the rigid pavements, they are mainly prepared with the reinforced cement concrete. Also, in some cases, we can use the PCC. But the factors will be different. Obviously, in case of the textual pavement, we will be taking the resilient modulus, Poisson ratio. But in case of the rigid pavement, we will be taking the modulus of substrate reaction, modulus of elasticity, Poisson ratio, etc. Now, what are the failure criteria? Obviously, the failure criteria here, the textual pavements like the fatigue cracking, rutting, thermal cracking. I will be giving another note of this particular thing, the pavement distresses, and the rigid pavement. In case of the rigid pavement, it is fatigue cracking again, but pumping or erosion is there due to the fact that it is made of concrete, and faulting of joints. In case of the rigid pavement, we have seen that the joints are also provided with the help of the dowel bars and tie bars. Obviously, I'm not going into the details about this. You can read it out. Obviously, the air-filled pavements are not included in your syllabus. The difference will be obviously there. The load will be different in the air-filled pavement with respect to the highway pavement. Now, I have attached a few pages from the IRC3. Okay, these are pages which will be required, so that is why I attached them. Here, what is given is that the different types of definitions are there, axle group, etc. You can read it out when I'll be giving you the PDF. But the main thing that you need to understand is the different types of vehicles as per the IRC recommendation. So these are the notations for the vehicles used, type 2, type 3. So these are the different types of vehicles they have shown in the particular figures. You may not need to remember all of them in case of your examination, but as it is included in your syllabus, I think you should understand a bit about it. When the first letter of the name indicates the S, if it is S, then it is semi-trailer, and the letter immediately following an S will be the number of axles. Okay, so in this way, you can easily remember the name. So this is type S2. Here they are written. Okay, S2 means it is semi-trailer and having two axles. Here two axles are there. Okay, then S1 semi-trailer, one axle is there. Okay, they are talking about the rear axle, obviously. So in this way, we will need to remember the name of the vehicles or the different types. Obviously, Even in your geometric design concept, you have heard that the width is 2.5 meters. Then different heights are there. Obviously, they should not be having height exceeding 4.75 meters due to some restrictions while they will be moving in the different types of region. Well, there will be definitely the railway tracks, so overhead wires will be there, overhead cables. So if a vehicle is exceeding 4.75 meter, then it will be causing problem to that particular region. And they have given some restriction about the weight also, due to the fact that we are going to design the pavement for few of the vehicles, not for all the type of vehicles or the overloaded type of vehicles. So in that particular case, the maximum permissible gross weight will be given as per this particular table. You can go through this, but you do not need to remember all of this. So this is it for today. Obviously, I hope that you, after getting this particular PDF as well as its notes, it will be easier for you to understand the total or the few things about the traffic consideration in pavement design. Obviously, there are more things in your syllabus which I will be discussing in the subsequent classes. Thank you.